Hi, we're looking at Unit 2, Lesson 12, and we're going to be discussing um, looking at two-digit by two-digit multiplication and comparing three different models. Now, when looking at two-digit by two-digit models, you need to remind yourself um, like 37 is actually, when broken down into expanded form, is 30 plus 7, and 24, because we're looking at 24 times 37, is actually 20 plus 4 when looking at that in expanded form. So that's 20 plus 4. And what that really means is that if you are multiplying by tens and you're breaking 30 down and 20 down into the form that we looked at in lesson 2, we looked at 30 being broken down into 3 times 10, because that actually 30 means that it's 3 tens. And if you were to break down 20, it would be the same thing, which would mean 2 tens, or 2 times 10. I'll make that into a multiplication. 2 times 10. So in essence, when they're breaking down 24 times 37, they're saying 30 plus 7. And if you break that down even farther, that means that there's 3 tens. And if you break down 20, that becomes 2 tens, or 2 times 10. So the reason that I'm telling you that is because you're probably looking at these huge area model right here and wondering, well, I don't understand why there's so many dots. Well, the reason that there's so many dots is because if you were to take the tens, 10 times 10, you would get 100. So this is 30, right? So you have 10, 20, 30 here, and this is 20. You have 10, 20 here. So if you multiply 10 times 10, which is in essence what they've done, they've taken this first area and they've broken it down into 30. So we're going to go 1, 2, 3. So this is 10, 10 here, 10 here, and 10 here, which is 3 tens, right? And then you have 20, which is going to be 10, 2 tens, and 10. Now if you look over here, it shows if we see 10 times 10, that means that's 100. So inside each of these boxes, we are now putting 100. That's why you see all the dots. So if you have 100 here, you know 10 times 10 is going to be 100 here. And you know you're going to get 100 here, 100 here, 100 here, and 100 here. So all together, these 6 boxes would be 6 times 100, which would give you 600. So we have 600 here. And now when you have the 4s, you have 4 down here, but you still have 10 up here. So let's draw our big box using this area model. And within this box, you have this crossover, and you have your 20 times 30 up here, giving this whole area the numerical value of 600. Now, looking at this area, I know there are 4 down here, and there is 7 up here. But remind yourselves that these are 10s all the way across and 10s all the way down. So when you have 4 times 10, because remember this is broken up into 1, 2, 3 10s, and this is broken up into 1, 2 10s. So this is 3 10s up top, 2 10s on the side. So this ends up becoming 40. This ends up becoming 40, and this ends up becoming 40. And then each of these are going to be 7 times 10. So you have 70 here, and you have 70 here. And then when you multiply the ones place values, you should end up with 28 here. And that seems like an awful lot. But when you add that up, you have 600 plus 120, which would be these 3 together, plus 140 plus 28 will give you the answer to your multiplication problem, 24 times 37. Now that's one model. So when looking at the area model, we looked at the array here, and looking at the area model, we're just removing the dots. So we're multiplying 4 times 30 and getting 120. And the place value section now takes each of these and pulls them out and says 600 plus 140 plus 120 plus 28, which is what we got in our very bottom figure, and adds those up and gives you partial products, area model, array model, and place value model all give you partial products. And the same partial products of 600 plus 140 plus 120 plus 28. And all of these partial products added up gives you the final product of 888. And that is the total of 24 times 37.